So our first lesson for today, we're going to look at some function operations. If we look down here, there's a list of the 4 function operations. We're going to learn about addition, subtraction, multiplication, and division. So when we first look at addition, this is the most standard form that your addition could be given to you. They're going to tell you you're going to take the function f, you're going to add to it the function g, and this x out here at the end says, hey, they both have to have the same variable. The variables in both of them have to be x. The easiest way to look at that is you're going to take f of x plus g of x. You're going to take function f that has a variable of x, and you're going to add to it the function g that also has a variable of x. That's what those little x's mean, that they both have to have variables of x's. Similar process for subtraction. So all that's changed here is the subtraction sign here and here. You're still taking function f and you're subtracting function g. They both have to have variables of x. Multiplication, we're going to take f times g of x. So our multiplication symbols here, this x is telling us, hey, they have to have variables of x for you to do this. And then we're going to simplify that as f of x times g of x. A lot of times these are just box problems. And then division tends to be my favorite. We're just going to take one function, put it on top of a fraction, the other function, and put it on the bottom. A lot of times they will give you an x value to plug in just to make it a little bit harder. Flip to the next page. So we're going to start off by practicing adding and subtracting functions. Really, this is nothing more than combining like terms. So once you get the problem set up, all you need to do is combine like terms, especially on this question on the right or the left-hand side where we're adding these functions together. So we're given f of x equals 3x plus 8, g of x is 2x minus 12, and then we're asked to find f plus g of x and f minus g of x. So here's what they might tell you, hey, find f plus g. The x is going to be in a little set of parentheses beside it. That really means take the function f of x and add to it the function g of x. So we're going to start by writing down f of x. F of x is currently 3x plus 8. So that's our first function. That's f of x. The symbol in the middle is addition. So we're going to say, well, hey, we're going to add the second function. The second function is 2x minus 12. Since this is an addition problem, there's really no extra work to be done other than we need to simplify this by combining like terms. So I'm going to combine like terms with the 2x and the 3x. Well, 2x plus 3x is 5x. Then I'm going to take the positive 8 minus 12, because it's a negative 12. 8 minus 12 is negative 4. Oops. So final answer here, 5x minus 4. For the second question, that's where things get a little bit trickier. So we're changing from addition to subtraction. The first step's going to be the same. We're going to write f of x in parentheses, then we're going to write a minus sign, then we're going to write g of x in parentheses. So almost the exact same first step as the one we just finished, except we're going to have a minus sign in the middle. So we're going to start with the 3x plus 8. This time we're going to have a minus sign, and then the 2x minus 12. So that's step 1. Step 2, we need to get rid of that minus sign. Like I've been telling you all term, that minus sign, if you don't distribute it, you will probably lose it. So we're going to make this positive and then change the signs of everything that's in that second set of parentheses. So now we have a negative 2x and a positive 12. Once you have gotten rid of that minus sign, we just want to go through and combine like terms. So I'm going to combine here. 3x minus 2x is 1x. Remember, 1x is the same as x. Then we're going to combine the 8 plus 12. 8 plus 12 is positive 20. So this one's answer is x plus 20, or 1x plus 20. So really the only hang up on this one is forgetting to distribute that negative, which will give you the wrong answer. Questions on these two? All right, multiplying and dividing fractions. So we're given two new functions, f of x equals x squared minus 1, and g of x equals x plus 1. We're going to start at the top left question. We're going to take f times g of x. That means we need to multiply f of x, and we're going to multiply it by g of x. So we're going to take x squared minus 1, and we're going to multiply it by x plus 1. Well, in order to multiply two sets of parentheses, we either need to FOIL, or if we want to keep our work more organized, we're just going to draw ourselves a box out to the side. So I'm going to draw myself a box. In my box, we're going to take x squared minus 1 times x plus 1. So take a minute and fill out your box. Once we have our box filled out, we're just going to combine like terms to get our final answer. So when you fill out your box, you should end up with x squared, a negative x, a positive x squared, and a negative 1. So when we write our final answer back over with the question, we're going to write them our terms in descending order. So we're going to start with x to the third, plus x squared because it's positive, minus x because the negative x there, and then minus 1. And this right here is my answer for f times g of x. Sometimes they'll ask you to find f plus g of x, and then they'll change it up just a little bit like they did right here. And instead of putting an x in there, they're going to put a number in there. When that happens, you're going to take your answer that you just found and plug that number in for x. So we're going to take 2 to the third plus 2 squared minus 2 minus 1. So we're going to plug that 2 into the simplified answer that we just had. So 2 to the third plus 2 squared minus 2 minus 1. So this turns into a calculator problem. You're just going to use your caret key a bunch of times.
I have a question. How do you do it to the third power again? I forget.
You're going to use your caret key button.
Uh-huh.
And then you're just going to type a 3.
Oh, that makes sense. Okay. Okay, thank you.
You're welcome. What'd you get? 9. You should get 9 for your answer. I know some of you, if you're working at home, you might have to do this piece by piece. You might have to take 2 to the third power, which is really 2 times 2 times 2. So that would give you 8 plus 2 squared, which is 4, minus 2 minus 1. Well, 8 plus 4 is 12, minus 2 is 10, minus 1 is 9. So you could do this one term at a time and then just simplify your answer. But if you've got a calculator that can do it all at once, it'll just save you some time. So that's what happens if they take that x out and they replace it with a number. You just plug that number in for x. So that's multiplication on the right-hand side. Now we're going to look at division. So the first one, we're going to take f of x divided by g of x. So really that means, again, we're going to take f of x and we're going to divide it by g of x. For the purposes of this question, all we have to do is create a fraction and write f of x on top. Anybody notice anything about this? Can't do that, almost. So the top of this is a difference of squares. It's a perfect square minus a perfect square. It actually factors into x plus 1 and x minus 1. Again, remember, anytime you have two terms, a minus sign in the middle, and they both happen to be perfect squares, you can break it up into two factors that are exactly the same other than the signs in the middle. So the square root of x squared is x, so we put x in front of both sets of parentheses. The square root of 1 is 1, so 1 goes last in both sets of parentheses. Remember from last week, what do we have to do now?
Cancel.
We're going to cancel, so we have the x plus 1 on the top, the x plus 1 on the bottom. So this actually just simplifies to x minus 1. The majority of the time that you're given a question like this, it won't factor. They're probably going to give you something that looks more similar to what's on the bottom. So for the question on the bottom, we're being asked to find f divided by g of 2. So they've taken that x out and they've replaced it with 2. Since we've already simplified f divided by g, we can actually just go up here to our previous answer here and plug that 2 in. So technically, we could just take 2 minus 1 to get 1 as our answer. However, if we hadn't have already simplified this, we could go back to f of x divided by g of x, so the x squared minus 1 over x plus 1, and we would just plug that 2 in. So we would plug in 2 squared minus 1 divided by 2 plus 1 and still get that same answer of 1. So if you would simplify that individually, the numerator, 2 squared is 4, minus 1 is 3. And then the denominator, 2 plus 1 is 3. 3 divided by 3 is still 1. So there's kind of two ways you could do that depending on what you had done previously. If you hadn't simplified it, we would just do what's over here off to the side. If you've already simplified it, just plug in the number that they give you. And I know there's a question similar to this on your next test, so be warned. Questions on that? So that's adding, subtracting, multiplying, and dividing functions.
I have one question, I'm sorry.
Sure.
Okay, so with the adding and subtracting functions, I am confused in where we're plugging in. So I see it says f plus g, and then you took times x. So why did you pick the fx to plug there? If that makes sense. I don't know why I'm confused.
Does not make sense. So I'm just going to run back over it because I'm not sure about your question. This right here tells us we're going to take the functions f plus g. This x that's sitting over at the sides isn't telling us that we're multiplying it by x, but it's indicating that the variables must both be x in both functions. So we can't take, or they don't want us to take, like a function f that has a variable of x and then a function g that has a variable of a and put them together. They want the variables to match. So that's really what that means, and that's why we break it apart into this f of x plus g of x, saying, hey, the function f must have a variable of x plus the function g, which also has to have a variable of x. Does that help? Okay.
Yeah, that helps. Thank you.
Any other questions? Okay. Running along the same type of processes, we're going to look at composite functions. Notice the symbol here has changed. This is not a multiplication symbol. This is a composition. That's really just a fancy word for substitution. We're going to take one entire function and we're going to plug it into another function. So we're going to take, say, this function and we're going to plug it into that function. Whatever function's closer to the x is the one that gets plugged into the other one. Sounds really confusing, but really we're just inputting one function into the other using substitution. Oops. So here we have two functions, f of x equals x minus 2 and g of x equals x squared. For the question on the left-hand side, we're asked to find g of f of x. What this means is we're going to take this function and we're going to plug it into that function. So we're going to find f of x first. F of x is right here. I'm going to put it in parentheses. And then I'm going to take that entire set of parentheses and I'm going to plug it into g of x anytime I see x. So this x is going to go away and I'm going to replace it with the parentheses up above it. So I'm taking that x out and I'm going to write x minus 2, but then the squared has to be brought down. So we took the x out of g of x and we replaced it with the entire function f of x, which happened to be x minus 2. And now we want to solve this or simplify this, which is just a box problem. So we're going to box x minus 2 off to the side. So we're going to take x minus 2 times x minus 2. So when I simplify that, it's going to give us x squared minus 4x, because negative 2x and negative 2x combined to give you negative 4x, and then plus 4. And that right there would be our final answer. For the question on the right-hand side, notice the order of the letters is different. Now we're going to take g of x and we're going to plug it into f. So I'm going to find g of x first. I'm going to put parentheses around it. And then this time I'm going up to f of x. I'm taking out the x that was there and I'm replacing it with whatever I have in parentheses. So in this case, I just have x squared in parentheses. Then I'm going to bring down the minus 2. For this question, I can't really do any simplification. I don't have any like terms. Your answer is just x squared minus 2. You technically wouldn't have to rewrite it. You could leave that x squared in parentheses. It just looks nicer without it.
So why do you do g and x again?
So whatever function is closest to the x is the one that you plug in to the other function. So g was closest to the x, so that's the one we put in parentheses, and we plugged it into the other function for x. So we're taking an entire function and we're plugging it into another function, taking out the original x in that function. We're going to practice some more, I promise. All right, so on the next page, we have two new functions. We have f of x equals x minus 7 and g of x equals x squared plus 7. So for the question on the left, we're going to take f of x and we're going to plug it into g. So f of x, or f, is closest to x, so I'm going to put f, the entire function, f of x into parentheses. So the x plus minus 7, sorry, the x minus 7 goes into parentheses. And then I'm going to move that down here where this x was. So I'm taking that old x out and I'm replacing it with the whole set of parentheses, in this case, the x minus 7. So I'm going to have in parentheses x minus 7 squared, and then bring down the plus 7. So I've taken out the original x that was in g and I've replaced it with this whole set of parentheses for function f. And now I want to simplify. In order to simplify, I have x minus 7 squared, which is a box problem. So off to the side, I'm going to box x minus 7 times x minus 7. Well, x times x is x squared. Negative 7 times x is negative 7x. Negative 7 times x is negative 7x. And negative 7 times negative 7 is positive 49. When I combine like terms, that's going to give me x squared minus 14x plus 49. Do not forget to bring down this plus 7 that was hanging out at the end. The last thing we need to do here is combine like terms right here to get x squared minus 14x plus 56, final answer. Questions on this one? All right, for the question on the right side, we're going to find f of g of x. So we've switched the order. This time we're going to take g of x and we're going to plug it into f. So we're going to put parentheses around g of x. And then we're going to go to f and we're going to take out the original x and we're going to put in that entire set of parentheses. So take a minute and see if you can get that. If you're feeling brave, go ahead and simplify. So when we do that, I again took out the original x and replaced it with x squared plus 7, and then the minus 7 comes down. Now when I look at this, my set of parentheses isn't really necessary because nothing's being squared. There's no numbers out in front. So we can just ignore those. And then we just need to combine like terms. Well, positive 7 and negative 7 cancel. That leaves us with an answer of x squared. So notice how we took the same two functions here at the beginning, we plugged them in different directions and we got two completely different answers. So order really matters on these. You're always taking that highlighted function and plugging it into the one on the outside. So that's why I highlighted them and I drew the arrow to the one that was on the left. We're taking the one closest to X and we're plugging it into the one on the outside. Questions on either one of these? They take practice. All right, last but not least, this is an updated version. So some of you who are working online might not have this version. So here we're given two new functions. We're given f of x and we're given g of x. First question, we're asked to find g of x. Well, we only have one g, right? First thing I suggest you do is you're going to write g of x again. Because we're asked to take g of x and plug it into g of x. So we're taking g of x and we're going to plug it into g of x again. So I'm going to put parentheses around one of my g of x's. And I'm going to take that entire set of parentheses and I'm going to plug it into the other one where there was an x. So I'm going to take that x out and I'm replacing it with the entire set of parentheses. So the -3 gets brought down. Then my entire set of parentheses, -3x plus 5. Close your parentheses, and then the plus 5 gets brought down as well. Now I want to simplify. Got to get rid of the parentheses. This time I have a number sitting out front. That number must get distributed in to those parentheses. So -3 times -3x. -3 times -3 is 9. The x gets brought down. -3 times +5 is -15. Bring down the plus 5. One last step, we need to go and combine like terms here. Gives me a final answer of 9x minus 10. Takes practice. We'll get there.
So you were able to take the 7 from the other problem because there was nothing by the parentheses, correct? How you did, like, you just made it like x squared because you took set plus.
Oh, yes. For this one, because there was nothing out front of it, we didn't have to distribute. There was no squared, so we didn't have to box anything.
Okay.
That's why I was able to combine those.
Okay.
Here, since we had that 3 out front, that 3 has to be taken care of before you can combine like terms with that 5.
Okay, cool.
All right, last one. I want you to see if you can take g of x and plug it into f of x. So put parentheses around g of x and then replace the x in f of x with that entire set of parentheses. So do step 1. All right, so we're going to take that g of x. We're going to put the entire thing in parentheses. So this right here, this whole entire function, -3x plus 5, is going to get plugged in right here for this x. So this x is going to go away. So I'm going to have 4, then my entire set of parentheses, then the squared minus 6. So I'm going to have the 4, my whole function g of x, negative 3x plus 5, then the squared minus 6. The only thing that's changed from function f is that original x is gone and it's been replaced with that entire set of parentheses, negative 3x plus 5. Also note, this has been labeled an important question. It may or may not have a similar question on the final. In order to simplify this, I've got to take care of this squared first. So I need to take these parentheses and square them. In order to square a set of parentheses, we're going to draw ourselves a box. We're going to take negative 3x plus 5, and we're going to multiply by negative 3x plus 5 again. So looking solely at that box, negative 3x times negative 3x is 9x squared. Negative 3x times positive 5 is negative 15x. Negative 3x times positive 5 is negative 15x again. And 5 times 5 is 25. So when I jump back over to my problem, we haven't done anything with this 4, so we're going to bring it down. We have simplified the negative 3x plus 5 squared, and that's giving us 9x squared minus 30x plus 25. And similarly, we haven't done anything with this minus 6. Anybody know what we're going to do next?
Asterisk?
If we do the asterisk, we're going to go back to the negative 3x plus 5. How can we get rid of the parentheses here? What do we need to do? Distribute. So we've got to distribute that 4 before we are allowed to combine like terms. So we're going to distribute the 4 to all 3 terms inside our parentheses. The minus 6 will get brought down. So 4 times 9x squared is 36x squared. 4 times negative 30x is negative 120x. And then 4 times 25 is positive 100. Bring down the minus 6 because, again, we haven't done anything with it. Our last step. What is it? Combine like terms. We have like terms sitting out here at the end. So 36x squared minus 120x plus 94 is our final answer. No need to factor that. That is your final answer. It's kind of ugly, but a lot of students just struggle with this first step of what to plug in where. It's always this highlighted piece over here on the right that gets plugged into the one on the left. Questions on this one? Again, it takes practice, it takes time working through problems to learn this. All right. Your next page, you have some practice problems to work on. Notice that this first page here, you are subtracting for this one. Whoops. So we're subtracting on the first problem. We're adding on the second one. We're multiplying here. It's our boxes. Multiplying for question 6. On the back side is where things start to change. So here's what we were doing with the compositions. So for question 7, you're going to take f of a and you're going to plug it into g. So f of a is what's going to get put in parentheses, and then you're going to plug it in right here for a. So that little open circle is what tells you you need to substitute one function into the other. The function on the right gets plugged into the one on the left.